Hello and welcome to IoT North. I'm Paul Wheels, founder of IoT North, and I'm going to bring in my good friend, Mr. Stavely. Hello, John. How are you?
Very well, yes.
Hello and welcome to IoT North. Oh, somebody's got us on. I'm going to bring in my good friend, Mr. Stavely. Is that on one of your links? Am I?
Very well, yes. Shoot that person, whoever that is.
Where is that coming from? If people can't hear it.
Yeah, I think that's gone.
So it wasn't me this week, it was you. Yeah.
Oh, no.
Busted. What you been up to lately, John? What you been up to this week?
I'm still waiting for my IT project to kick off. Contractual stuff is just going on forever and ever. But it is conference season, which has been keeping me busy. So I was at MS Build down in Microsoft headquarters in Reading a couple of weeks ago. They're obviously spending billions on IoT, so they think it's going places. But one of the slides that was interesting is like there's an adoption curve, the innovators, early adopters, early majority, and they said, well, we are here at the early majority. It's about to explode, and that's kind of my impression of the IoT market at the moment. There's lots of people talking about it, but are they spending money?
Yeah, I've been looking at the Gartner hype scale quite a lot recently, and especially around Edge and AI vision and stuff, and very relevant to Steen, which we'll bring in from the green room very soon. Interestingly, computer vision is ahead of Edge AI, but I think there's technologies and tools that are coming out that are starting to pull it through, and it seems to be definitely what I'm seeing and hearing in the market. One of the things I'm finding really interesting is who are the real players with Edge IoT platforms. There's some interesting stuff that I'm observing, and I'm going to pull in Steen, who's our guest this month even. Hi, Steen. How are you doing?
I'm doing great. Thanks for having me. I really appreciate it. You guys have built this outstanding platform. You have this great community, and when Paul mentioned it to me last time I talked, I was just thrilled at how some critical minds were going to get together to talk about connecting the physical world to the internet. And I have to say, at the onset of this conversation, when you guys are chatting about the hype curve, it really made me feel unfortunate. And I think a lot of us that work in the technology industry know that the timing can be extremely important. But at the advent of the terminology IoT, I was living in Taipei, Taiwan, running Intel's embedded sales group, which was, at the time, not a very glamorous job. It was kind of all the non-PC, all data center business. And, if you were really good fast riser at Intel, you'd be running that server group at the time they called it, or you'd be working in client computing. And then they threw everything else, all these embedding computer chips and digital signs, human machine interfaces, and panel PCs, and, all automotive applications into a different group, along with Ethernet, memory chips, and cable modems, and small cell acquisitions. And, I remember my boss coming to me at the time and announcing that, that there's this new term, IoT, and, we're going to see 50 billion connected devices, out over the course of the next decade or so. And, for me, what it meant leading a team of sales professionals, marketing, business development professionals, and technical support people for our customers is it meant my quota expanded immediately when the term came out, right? So, the growth rate expectations doubled for me and my organization, and accordingly, our commissions quotas expanded, double. And so, today to kind of hear, Paul, you and John talk about the hype curve and spending money, I completely agree with the dialogue. But for someone like me that's been in this dialogue for over a decade, there's a lot of wounds, a lot of failures, and a lot of learnings, over the course of that. So, and that's really part of my talk today. I just want to talk about how, it's the timing is fantastic, to your points earlier. So thrilled.
Yeah. I mean, I've been in IoT, excuse me, my first IoT project was in Telstra in Australia, and that was creating a gateway connectivity to turn energy on and off as a proof of concept for the Department of Defence in the outback. And even back then, they were talking about the starting to this IoT machine to machine evolution of telemetry. capability, and there's been these huge numbers as a can being kicked down the road several times, to be fair, on how it was going to be delivered and how much was going to be delivered. But I do kind of feel this year there is a bit of a change. I think the COVID impact has definitely had a positive impact in regards to the adoption of the technology. There's been that recognition from, especially in the industrial market, about how a lot of places could have kept on going with minimal staff and having automation and even observation with fault detection and so on and so forth to try and minimize risk and whatnot. John, when was your first project?
Still under NDA, but it was integration to like an FMCG production line, turning out millions of units of stuff, and gathering data from the production line and pushing up to central server so that service engineers can identify faults on the line.
And when was that?
Middle of last year it started. Beginning of this year it ended.
What was that was your first IoT project?
Well, I mean IoT Edge. I've done lots of embedded stuff, but I wouldn't really call that IoT.
Yeah.
Before that,
wow.
Yeah.
I didn't realize that. I thought you'd been playing around with the Edge and IoT stuff for a little bit longer, especially considering we've been talking quite a lot on shows in the IoT space for a couple of years.
I'm mostly doing embedded stuff. You can call it IoT if you like. Yeah.
Hey, so if whoever's online today, you can chat to us on the chat options in regards to if you're using LinkedIn, Twitter, or YouTube. If you're on our website and you're watching it through there, if you don't see the chat option, just click on the video and it'll take you to YouTube and you'll be able to ask questions. I'm sure Steen would love loads of questions to him, and I'm sure he'll happily share his insights. So, Steen, what's your talk?
Yeah, let me pop this up. I've got, I was told by Paul earlier I'm a cool kid because I use Canva now, so I was thrilled about that. And the founders of Canva just, I mean, they did a really nice job with this platform. So shout out to the Canva team on enabling our creativity as we modernize what traditionally is great PowerPoint based content. So one of the things that I wanted to talk about today is the ripe context that you guys set, which is, we've been waiting for this IoT hype curve for folks like me a decade plus. I think one of my first projects was back in 2013, 14 with an air compressor company, actually the fourth largest or fifth largest air compressor company in the world at the time, Fuxing, who, the CEO, he had an incredible vision about providing air as a service, compressed air as a service. And as you probably know, in modern economies, air compression can take up like 8 to 10% of the electrical output and powers, many applications in factories today, including, semiconductor facilities powered by air compression. And being able to continuously monitor that and service that, so you can get the right product at the right place at the right time to optimize uptime can be incredibly important. And I think over the past decade, I've went through all of these experiments and deployments that were really successful as well. But everything has seemed like a snowflake, and getting repeatability has been challenging. But the incredible ability today and the maturation of technology to drive industry transformation. And so, I just kind of wanted to talk about, three underlying trends that I see that make it incredible for people like us to be interested in connecting the physical world to the internet with IoT. And so I think, obviously we talked about at the onset of the call, the pandemic and really the pace of change in everything in humanity is only accelerating. And, you can look at the list of companies that are traded on the S&P 500 and, a decade or to the course of the next 5 years, the disruption is occurring at a much more rapid pace historically. And, the shout out to Paul's current company and former CEO, Andy Grove, who's also the 1997 Time Person of the Year. Andy famously wrote, you could be and I'm paraphrasing, you could be the subject of a strategic inflection point, or you could be the cause of one. And what he meant by that is, your business can be disruptive by someone that enables transformation, or you can transform your business. And I think that's a huge platform to drive the physical world to connect to the internet and drive industry transformation. And I think most importantly in my mind is the technology deploy is maturing at a much more rapid pace than I had seen, over the course of like the first 5 years, the advent of the terminology IoT. There was a lot of learning going on and a lot of development of standards, but for a developer, for an enterprise developer to use that technology and deploy it, it was still slow going. And I think the last 18 to 24 months have been dramatic. And one of the things I think early on we always talked about in IoT was what's the killer app? And I think one of the challenges you find is when you connect the physical world to the internet, being able to capture that information and understanding that the half-life of that data is much shorter than data you would traditionally put in the cloud is incredibly important. And so being able to do deep learning at the edge so you can capture insights on that half-life of that data that's much shorter is incredibly important too. So, the pairing of connecting those assets and then applying deep learning is really very critical. And not to mention the amount of microservices and maturation of those technologies today allow us to build edge to cloud IoT solutions with AI much faster than ever before. And kind of the final trend I find that's very important and is really the convergence of operational technology and information technology, and even communications technology as well. So when you put OT, IT, and communications technology all together, there's an incredible opportunity to transform industries and ultimately enrich lives and provide more compelling services. So I think that convergence is ripe. Been in those conversations on operational technology and information technology. And one of the things that we always talked about is introducing the people that rack and stack with the people that hang and bang insofar as they're installing cameras. And I think that technology is much more mature today as well. So those are kind of the three trends that I want to talk about. And I thought it'd be fun maybe to just like talk about building real solutions built on Internet of Things technologies, those microservices and artificial intelligence, and how rapidly we can put together the technology solutions to address some of the challenges we're facing today. And one of the hottest topics I think in the market today is certainly inflation, and it's happening on a global scale. And one of the many challenges that have been driving inflation is the bottlenecks at ports. And if you look in the U.S. at the port of Los Angeles and Long Beach, roughly about 40% of container traffic goes through those ports in Southern California, and the majority of that traffic is coming over from the port of Shenzhen or Shanghai. And to actually just make that transit across the water, it's only about 15 days. And in pre-pandemic, though, to actually the turn time or that operational technology metric to transit and then unload the ship actually took about 70 plus days. And then at the height in the pandemic, you were seeing over 125, 130 days. So a massive amount of time, essentially spending like a third of the year for goods in transit. And what that did to, containers and the cost to $2,000 to $15,000 to $20,000. Shift in people moving and everybody was really excited about getting, their back porch set up, or, whatever home modernization project that they needed to work on, that allowed them to make use of their home better, because they couldn't go out and dine at great restaurants because of the pandemic. And so we saw peak, traffic at ports and peak volumes. And, one of the things that we found, and I think for the folks on this call, I think, you see like the Port of Rotterdam is a very modern port. In areas like the U.S., they didn't modernize all functions in the port. So the front end of the port process of unloading container ships is automated, but one of the areas that's not fully automated is loading and unloading the trucks. And if you look at, like, according to the California Maritime Association, it takes about 8,000 trucks to unload a full ship. And what happens is there's union longshoremen that operate the rubber tired gantry cranes that load and unload those trucks. And one of the areas that you saw a lot of finger pointing at the height of this crisis is the truck drivers were actually blaming the crane operators for not knowing their station really well, taking too long of breaks, etc. Meanwhile, conversely, the crane operators were blaming the truck drivers for no showing 50% of their appointments. And one of the things that we thought would be interesting is, how can we take kind of great IoT technology, artificial intelligence at the edge, and instrument those ports in a faster way on existing infrastructure. So it's not a full rebuild. Obviously, it would take too long to rebuild a port or rip out current systems. But how can you deploy AI and IoT services on existing infrastructure quickly to analyze some of this stuff? And so, one of the other things that we looked at is also is safety. With every industry, the safety of the employees is really the most important goal that they have. And when you're moving around these really heavy objects with high value heavy equipment, you need to make sure your workers are safe. And so the other attribute of this solution that we looked at is, as port congestion was growing dramatically and you're getting more green operators, how can we enhance safety? And so as you operate some of these cranes, you have obstructed views. You don't get a full 360 view. And so we thought it'd be cool to add some kind of modern based AI tripwire detection safety to this solution as well, and alert operators when it's safe to proceed. And so if you look at just kind of the edge architecture, and this, this solution is edge to cloud, and I'll talk a little bit more about that. But if you just look at the edge architecture to kind of get this up and running, in kind of the start of my talk, I just talked a little bit about the ripeness of microservices and the maturity of the ecosystem. We were able to take off-the-shelf NUC class solutions from Intel. We were able to run both Linux and Windows. And running Windows is important because if you look at like the ports, there's a big install base on Windows. You get companies like Siemens Simo Crane runs on Windows, so it's there's existing infrastructure that's running on Windows, and then there's existing applications like Windows 32 apps. There's actually an alarm manager to notify the crane operator when it's safe to proceed. And so that's a legacy Windows-based app that you really want to pair with modern-based AI services that sit in the Linux-based technology. And so in this particular solution, we used the OpenVINO toolkit. We actually built some custom layers around license plate reading so we can make sure the truck's at the right place at the right time, people detection, and then application logic around tripwire detection for enhanced safety. And so bringing microservices like video, like a database technology, like a video server technology, being able to start off with an RTSP simulation. And these are all great ways to kind of move forward. And in this solution, I think one thing that's cool that we used OPCUA, the machine-machine protocol, to communicate from the Linux-based environment where we're analyzing things like whether it's safe to proceed to the legacy Windows-based environment as well. So this is stuff that we got up and running. that at the advent of IoT would take us years, that really took us weeks to get up and running. And then in this particular solution, we also used Splunk Enterprise, really deep, great machine log information and dashboarding and insights. We ran on top of Azure Cloud. And we use this great technology from Microsoft Edge for Linux on Windows. That is if you're familiar with Windows subsystem for Linux, it's a kind of an edge version of that that's more commercial in implementation that allowed us to run Linux and Windows concurrently, on affordable off-the-shelf hardware from Intel. And Intel provided us a great para-virtualization driver to get access to the integrated graphics through the Windows-based OS in that Linux environment where we're running the AI that allowed us to run multiple camera feeds and multiple AI models concurrently. So that was kind of a fun underlying capability that allowed us to do this affordably. And this is just kind of a fun, the operator view that we built out, multiple camera feeds, of course, detecting the truck, license plate detection, reading it, entry time, work order ID, container ID, starting to monitor that operational technology metric that helps us understand the throughput at the ports, which is the turn time, how fast the truck can be loaded and unloaded. And then we got operator alerts on this dashboard to notify the crane operator when it's safe to proceed as well. And, this is fun. We just kind of did another Windows-based UI just to demonstrate a couple of things here. Is one, the machine-to-machine protocol in action, notifying that legacy application, the alarm manager application, using the modern AI services, again, from Linux to Windows, using the machine to machine. In this particular AI models and in our custom model, 11 gen quantum, things, to get up and running that, again, took us a few more weeks of work, but just really rich insights from Splunk on dashboarding. And one of the goals that every port has is maintaining CO2 emissions. So we're tracking fossil fuel burn and CO2 emissions, ultimately for sustainable that are a mix between hybrid and diesel. So you can see here could reroute operations to ship more trucks into the hybrid crane if it's available, therefore lower emission status. And of course, all these operational technology insights around the cranes, including safety violations as well, which will notify us how well an operator is doing as well. And so this is kind of a great way to get technology up and running. And again, this is something that would have taken us considerable amount of time longer, but now kind of with using the microservices, just having the forwarder capability to Splunk is giving us the ability to absorb all this great IoT data into real-time insights. You can look at across terminals, across sites as well. And if you're really interested in this solution, we go through in a step-by-step guide about a 17-step guide on how to get this up and running. And so if you don't want to go through the pain and suffering that we did on building this from scratch, and you want to have a curated kind of guide to do it, you can check out our YouTube and get access on how to run this solution. And also, we partnered with Arrow on this solution. So if you're interested in getting the code, you can send a note out to Scott Schimmel over at Arrow to get access to that code. And you can, again, save hundreds, maybe thousands of hours in development on a solution like this as well. So I don't know, Paul or John, if you have any questions about that. I was going to kind of show another fun example.
That's one, Canva does make your slides look great, doesn't it? But two, the content really helps as well. That was really cool. So how many models did you have there? On the image that you had, where you had the truck, you had the space in front of the truck, and then you had the identifier of people as well?
Just two camera feeds, two models. So we're just running off the shelf OpenVINO people detection. And then we used application logic to do the tripwire detection, right? Which, I mean, there's so many, one of the things that I've learned is actually application logic around tripwire plus people detection is a really nice use case, because and it scales to a lot of industries, because like in public safety and security, you can get like, a lot of false alerts where, for example, like a raccoon comes in and breaks a perimeter, that nobody wants to send a notification to the security professional in that regard. And so being able to do people detection is really helpful with the application logic of tripwire detection. I'll show you kind of how we use that in a worker safety implementation as well. But yeah, two camera feeds, 2 AI models. And we were showing that solution, and one great AI ISV came up to us and said, wow, how are you guys running multiple camera feeds, multiple AIs on what they said was $1,000 box? I don't know the current price of the NUC from Intel, but they thought that was affordable, because one of their customers was telling them, hey, you're going to get designed out of an opportunity because you're running on $10,000 hardware. Two camera feeds, 2 AI models. And so I think one of the, the affordability of doing this stuff and then running with existing infrastructure is really important as well.
I totally agree with you. I think it's one of the interesting things that for the real scale, the cost really did need to and does need to come down in regards to the hardware side of things. And I think that is starting to come through. There was once a great developer kit called Visi AI from a company called AD-Link that really helped hit that price point. There's still about 15 of them left on Arrow. I might still sadly check on Arrow every week, waiting for that 0. But when you get down to that type of price point where it's like $200 and using the Movidius for your inferencing and the CPU and stuff that's on there as well, $200 you'd probably be able to run them 2 models on it. We do have a question come through from Mr. Wallace. Hi, Dick. Nice to have you online again. To what extent is your solution self-funding, e.g. through fuel and time saving, and what do the unions think of it, e.g. job losses?
Yeah, so this solution, just to kind of do inverse order, this is not changing any job impacts for the unions. So, this is a solution that just enhances their situation and gives them additional insights. And so if you look at like some of the other newer ports that are getting built out at a global scale, they're going fully autonomous, mobile loading and unloading. But in particular, in the U.S., they're keeping those union jobs. So this is just kind of an enhanced insights, for the unions. And what was the first part of that question again?
To what extent is your solution self-funding?
Self-funding. Paul, you might have to help me define self-funding. Oh, insofar as when it's so certainly in the U.S. As part of the infrastructure bill, there's about $17 billion to modernize ports. So that's kind of an incredibly important metric as well. And then the ports obviously, monetize the traffic at the ports as well. So when we're able to enhance the throughput of the traffic, we're able to increase, monetization there. And then the other opportunity is based on, fuel consumption as well, and being able to reduce the fossil fuel consumption. These cranes burn on average about, if it's not a hybrid crane, about 10 gallons of diesel an hour. So really heavy fossil fuel burns. So I haven't, to be fair, I haven't done the full math across every implementation, and we're in early stages talking to ports right now. But you can just kind of go say, okay, well, off the shelf technology from, Intel, very affordable. You get a couple off the shelf cameras, off the shelf NUC. The code is written. You guys can go check it out on GitHub. Obviously, there's some productization elements we've got since we wrote the first substantiation of the code. But I mean, this is a really affordable way. Payback period should be in months, or weeks, based on that fossil fuel burn and the turn time association. So,
excellent. Dick also had another question. Would a killer app be cutting the TRL in half as to accelerate the growth of HVM, much needed for UK recovery post-COVID?
Well, I think, Paul and John, you guys are probably just as adequately at answering that one as me, but I think it would be a killer app. But I don't know the local market as well as you guys do. Any additional?
Yeah, I don't know enough in that side of the market to be able to give an answer, to be honest. John?
No, it's all. I think it's all in a state of flux at the moment, so it's a bit difficult to sort of pin it down.
Yeah. Did you say that you had another use case to talk through?
Yeah, I wanted to talk about.
Can I just ask a quick question? And
yeah.
So when I did edge computing, it was all sort of like Docker containers deployed to the edge and via a build server. Is that the method you used? Or
Yeah.
something else?
Everything we do is, built in the cloud, deployed at the edge, containerized based solutions. So
is it specifically Azure IoT Edge that you were using?
Yeah, that's one component of that solution that we showcased.
Okay. Did you have cognitive services installed in another Docker container? So you had like your application logic talking to the cognitive services to do the image recognition?
No, we didn't use Azure Cognitive Services for this particular solution, just because we were able to kind of use off-the-shelf models from OpenVINO and then add some custom layers. But we did develop it we do have like a notebook in Azure ML as well. And actually in this solution, I'll talk a little bit about running, transfer learning, or maybe more colloquial said, retraining on top of Azure as well, which I think is another one that I think is an incredible indicator about how ready the technology is to be applied to solve some of these problems. Mm-hmm. So if we look at some of the industrial challenges, we talk about them, and obviously we've seen, especially number one again is making sure the employees are safe, and this is a metric that every company has that runs manufacturing. Quality assurance is incredibly important across the board. One of the challenges that manufacturers have is just getting real-time inventory insights as well, and especially as the prices of raw inputs go up and you want to hit sustainability metrics. Incredibly important to get real-time inventory insights. And then one of the challenges you find in manufacturing is, nobody wants to rip out their existing infrastructure that's been depreciated over time. So how do you deploy technology on existing infrastructure? And so that's kind of one of the things that I want to talk about here, including the ability to use inline AI defect detection for quality insights. Incredible opportunity, I think, where you're upstreaming the defect detection earlier in the manufacturing process. That's giving you insights to quality, and what that does is that saves a lot of costs on scrap and rework, which ultimately results in less commodity cost spend, which is a benefit for sustainability as well. So huge opportunity, I think, in inline AI defect detection, and that's certainly a technology that's reaching scale. One kind of fun open source data set to use is a data set that's like 7,000 to 9,000 images on impellers. As you guys know, impellers are used to do a lot of things for pumps, including prevalent in engines, pumping coolants in engines. So you want your impeller to work so your car doesn't overheat, for example. And one of the things that I wanted to share today that's kind of cool is, if you look at what we did here, is we conducted some transfer learning on Azure Intel-based Xeon instances. And this is why it's such an incredible time to work in applied AI, is because we're able to take a model like ResNet 50, which wasn't created to do impeller-based defect detection, that companies have spent millions of dollars training, building ResNet 50, some great data science worked on it, and then we're able to take that impeller data set, retrain that model, optimize it in OpenVINO, convert it to Microsoft's Onyx environment. And in this actually particular use case, we also added explainable AI, which is very important. But to do something like this, it's really less than an hour, and we got 99.7% accuracy. And I think it was all. If I look at my Azure bill, I'll go back and look at my Azure bill. It's also, I think, less than $1. to do something like this. So just think about that. I mean, to just get to ResNet 50, tens of millions of dollars, huge cloud bills, brilliant data scientists that build it out. But when we talk about applied AI today, making this actionable, it's really achievable for a lot of organizations and companies. So kind of a fun one that I want to share. Similar architecture where we're running OpenVINO based technologies. We're running Edge for Linux on Windows because there's a huge install base of Windows in factories as well. And of course, we know, modern cloud services run in Linux. We know AI runs in Linux. And so if we can get the best of both worlds there between Windows and Linux, then we can help deploy this technology faster, like inline AI defect detection. And so it's a little teaser. What's fun about, I'll just kind of show you a video here. So you can see the coloration, that's the explainable AI that we added to this solution. And so and one of the big, trends, obviously, in AI is making it explainable. We talked about that quite frequently on diversity inclusion use cases because in areas like facial recognition, where we want to make sure we're not getting, wrong information that are hurting a particular segment of the population. But in this case, we're just showing, where the impeller defects occurred as well. And we're seeing a lot of explainable AI being written into new tender opportunities as well. And it's becoming more and more of a regulatory requirement for a lot of governments. When you do AIs, we need to explain how it got to the conclusion here. And I know I talked a little bit about tripwire detection earlier and how it's just a great use case. I mean, one of the challenges in manufacturing facilities is as people walk around and they go into areas, you might want to notify the machines that there's now humans that are entering a zone, or you have a hazard detection zone. So you can start using tripwire detection plus people detection to notify that as well, which is a great insight. And obviously a site manager can't monitor all people at all time. And so creating those alerts and even using the machine-machine protocol, OPC UA client server, we can even notify the machines that humans are coming into a hazard zone as well. This solution's running really fast, by the way. Performance is really high on Intel's integrated graphics here. Again, using that virtualization driver, so pretty fun. This code is public, so you guys can go check it out if you want. And play with this. There's actually a how-to YouTube developer guide on the YouTube channel. It's Factory Solutions is the YouTube channel. It'll take you through step by step on how to get that impeller defect detection up and running, tripwire detection, manufacturing facilities as well. And at Microsoft Build, we actually launched this really fun augmented reality experience. So if you guys, want to go check out this cool AR experience, there's actually this virtual environment where Chuck actually goes through a smart factory and a not so smart factory. His car breaks due to his impeller defects. And I don't want to steal all the coolness of the story, but he runs into some worker safety issues as well. And then the factory is re-instrumented with AI technologies to make sure he doesn't have any impeller defects or worker issues. But it's a really fun augmented reality experience that we launched at Microsoft Build. You can check it out. It's going to ask for your camera access. That's all. It's required if you want to do augmented reality. So you got to be bold and provide that access. But fun little teaser that I encourage folks to set up. And that's kind of the culmination of the material I want to share with this team today. And love to answer some more questions or talk through some other ideas.
Dick had a question. It's on the screen at the moment.
The key US-UK defence contract, AX armoured vehicle, is way over cost and time. Could your technology advise MOD, DOD whether to can this project or maybe help correct it?
Dick, you've got some fairly elaborate questions here. I think it's fantastic. You're really putting my limited IQ to the test. But no, I think this particular technology that I was showcasing, I don't think could particularly help the Ajax project. I would be way too ambitious to say just that. But I do think, is one of the interesting things that I ran into recently is, I used to work and have kind of under my leadership an aerospace and defense team. And one of the things that the Air Force does, the U.S. Air Force does, is they have a solutions factory initiative where all of their product companies that they work with, they actually get them together to drive more interoperability. Because one of the problems that the Air Force finds is, hey, all these great companies make great products, but building solutions among those is really challenging, and that leads to program delays. And so, at Scalers AI, what we're really excited about doing is kind of being that solutions factory for all these great microservices and technologies and putting them together very quickly to drive industry solutions. And so, today I'm, in no way I think can we accelerate the Ajax program, but I actually, I think there's an incredible opportunity to make sure technology is more interoperable in that space. So that they don't run into these massive delays and cost overruns. And the U.S. Air Force is implementing that solutions factory just to do just that. So, yeah, great perspective, great question.
So with your company, Steen, are you predominantly focused on doing proof of concepts with customers and partners, or are you looking to build out those solutions that are scalable?
Yeah, so for us, we really have two goals and two kind of organizations that we want to bring closer together. One is the people that deploy the technology and service the technology and monetize that. And over the course of my career, in this IoT space, I've been taught by a few leaders in that industry very clearly that, when I work for a product company, that they don't get paid for investigating new technology and new products from product companies. And at times they're very annoyed because product companies are always trying to push the latest tech, right? Meanwhile, they're trying to sell what works, what they know it works, so they can deploy and service that technology with high fidelity so they can make money. And so there's always this natural chasm between product company launching their latest product that they want to push to market fast, and then the solution provider, be it a software provider, be it an OTSI or an ITSI, in deploying and servicing that technology so they can make money. And so what we want to do at Scalers AI is help the product companies accelerate their product market fit in industry leading solutions, complementing their core product and helping build a solution around it so they can deploy faster with that OTSI community or that solution provider community. Meanwhile, we want to actually help those solution providers get high fidelity solutions faster with the latest tech and solve their problem of making more money down channel. And so we essentially have two product offerings. One is essentially a subscription product for those down to channel solution providers where they can subscribe to our code, our support, our transfer learning tools, all the capabilities that they need to deploy some of this latest tech from product companies faster. And then similarly, we have an offering for product companies where we put a lot of code and insights around their core products to showcase them in industry solutions much faster.
Is there any particular reason why you were in stealth mode for quite a long time?
No, it's just a cool thing to say. It's just cool. Cool stealth mode. We're just getting rolling as a company, and I think we want to be humble and just work with new partners and gain momentum. And so I just didn't feel the need to.
Cool. Anthony has a question. In the context of us moving to Web 3.0, what would IoT 2.0 look like? Doesn't feel as though IoT has advanced to IoT 2 yet. Thoughts?
Yeah, Anthony, this is another great question, really high IQ question. It's funny because, in a lot of presentations that were very forward thinking, 5 years ago, everybody would say 1.0 is just get the devices connected, right? And then 2.0 would be, okay, let's run analytics and make decisions based on those connected devices. And then 3.0 would be these fully autonomous software defined experiences. And I think what I've certainly found is, yeah, it's great to say get the devices connected, but unless you can actually run analytics and AI on those devices, you don't have the ROI, and the project dies on the vine. And so I think, for me, I think that same kind of philosophy is accurate for today. Like let's 2.0 should be running deep learning at the edge pervasively, so you can get analytics and insights. I think would be a great 2.0 approach to it. But when you talk about Web 3.0, it makes you make me go down the doldrums of the metaverse. And I think
there's a few definitions of that anyway, some including blockchain, metaverse. Yeah.
One of the things I think is just kind of really, really interesting is, for those of us that kind of born on Web 1.0, the ubiquity of the web, and, there was no scarcity. All this digital information was available, affordably now like never before. And I think the concepts around Web 3.0 that make me a bit skeptical are the concepts around artificial scarcity. What made the web so great is we could provide all this information, all this learning, at scale. And then when you add these concepts like artificial scarcity, it's a great way to monetize stuff, which Web 1.0 kind of failed in monetizing for creators and innovators in a lot of cases. But simultaneously, does it hurt the democratization of the web? And I think, if you start overlaying Web 3.0 with IoT 2.0, then you look at things like, how do you actually provide data, maybe, in a private way, in a repeatable way? Because one of the biggest, challenges we have today is data sharing to build newer AI models to solve industry problems. And so I think where that's a win-win scenario, where there's concentric circles over line, is really the concept around if IoT 2.0, we can create data sharing across companies or across organizations, so we can build better AI models. And I think that doing that in a private sense that's compliant with local regulatory requirements and ensures kind of data can be trusted is I think a really interesting concept. But if you're working in the AI space right now, and especially at the edge, one of the biggest challenges you run into is just getting access to really really good data sets.
Could IoT 2 be like the edge being the dumb terminal again, and your fiber upticking all this data up to some central processor doing the AI there and pushing it back again?
I think there's always kind of a pendulum swinging in computing, right? We kind of we had the mainframe era, and then we have the PC era.
Yeah, I think is IoT about to be disrupted?
Yeah, I think it's funny because you kind of look at the you look at the four laws that are really driving why you would place compute closer to the service delivery point or the source of the data, and it's just the laws of physics is one point, right? Which I think is probably the easiest one to your point to offset, which good fiber connectivity and low latency, maybe you can address the speed of light. The number 2 point that you find is like the laws of economics, and because the half-life of the data at the edge is so short, and it doesn't make sense to just send it all to the cloud. So just being able to run edge compute so you can discard irrelevant data sets is incredibly important. But I think probably one of the most important reasons is just the laws of the land. Privacy, HIPAA, all the regulatory compliance around discarding data due to privacy, due to other regulatory requirements at the edge is incredibly important. So that's pushing for an edge node as well, despite if you can solve, John, to your point, physics. And then, finally, what I always like to think about it, is Murphy's Law. And I think anything that can fail will. And I think when you start putting some of your most trusted operational technologies, on the internet, you might want to just have a layer of fault tolerance at the edge. And computing, thanks to Moore's Law and all these incredible innovators and, people at Paul's company and others, is computing is becoming so affordable that that fault tolerance layer at the edge to complement the cloud compute, I think is a good investment.
Cool. I think we got one more question. If you got any more questions, please put them in the chat.
Steen. Sorry, John. I was just going to say. So there's, in regards to the edge, there's a different definition of the edge as well, though, isn't there, Steen? Because you've got like the at the point of the data, edge devices like the NUC that you mentioned in your talk, and then you've got like the near, as I like to call it personally, which is the the network edge. Now that may be an instance on a premise, or it might be the network edge. Which the telecoms are pushing quite heavily at the moment with the 5G connectivity on that. So with the 5G edge side of things, how do you see that scaling from what you're seeing?
Well, yeah. So I mean, obviously with 5G, there was the advent of this term called multi-access edge computing, and where people want to provide that extra computing nodes, and then actually we're kind of early days with a couple of telcos that created platforms, in IoT platforms. If you guys remember, there was M2X, there was Verizon ThinkSpace. I mean, all the telcos kind of toyed with this. The challenge is getting developer adoption and getting developer usability of those platforms. So there's been a huge number of partnerships announced around cloud service providers, which have developers with the telcos in regards to deploying like 5G services and using these extra compute, the multi-access edge computing nodes. And I think ultimately, it's all going to come down to, programmability and ease of use for developers. I mean, developers are going to want, if those edge computing nodes are available and they're easy to program to, they're going to be great to use and people are going to use them. If it's easier to go buy a NUC off Amazon and get it deployed, then people are going to program to that. And I think, the endpoint technology, Paul, I think that's the, I don't think it really matters where the compute, how the compute's manifested. I think what really matters is how easy it is for developers to program to that compute.
Does cost not come into that decision making as well? I mean, if you look at like a lot of, I'd probably say in the real world, the majority of IoT deployments have been out on Raspberry Pis, which are great for a proof of concept, and there are companies out there that have had them running out in the middle of nowhere for a few years and such like. But it's not what they were made for. They were designed as an education piece. But the reason why a lot of businesses adopted and used them is because of the cost point, the price point was right. Is that not part of that decision making as well?
Yeah, I mean, I think I think what people don't, the cost of Raspberry Pi, I think is one factor. I think what that community did a great job of, though, was building out the developer tools and then making it ubiquitous. And I think cost was probably the third factor. I think just being, you could get them, and then they were, easy to program to. And I think that those are really, key factors in that. But ultimately, ultimately though, when you start realizing, as much as Raspberry Pi is great, NASA's got an installation of Raspberry Pi, and I think, I've been into like some company's office that do DDS technology. I won't name the company, but not the one you're familiar with. And they had an installation of Raspberry Pis running DDS technology, which I thought was really cool. Like the same code that you're going to use for a nuclear submarine, you're gonna simulate on Raspberry Pis. That's kind of interesting. But as much as that's to be said, I think those of us that have kind of, John, you talked about this embedded industry that doesn't make us sound cool at all. But what you realize is there's industries that require certifications, that require, custom and rich IO and ruggedize. And if we're going to take computing to the physical world, right, these data centers are these curated environments where the atmosphere is maintained at a certain rate. The level of precision on the temperature is very high, but they're curated academic environments. You take computing to the physical world, we all know there's a reason for these ruggedized devices with industry-specific certifications with rich I/O, and ultimately the people that are seeing high ROI are going to pay for those. And so I think there's the balance, between those as well. And I think one of the challenges though is why people don't go for those more expensive industry-certified solutions is not because there's a little sticker shock when you start on Raspberry Pi and then you move up to them, but it's also programmability. And are those solutions easy to program to, or are those companies kind of hardware first companies versus software first companies?
I've had a very interesting experience with a board like that on paper looks fantastic, has great features, and it's an absolute pain in the ass to program.
Yeah, and
I mentioned you just spend hours and hours beating your head against the wall because the developer resources are poor, the documentation's poor, there aren't YouTube videos where people explain things, and as a developer, it just really slows you down.
I think that's actually a really interesting point. Is that one of the things that I've always evangelized about in the businesses that I've been in and worked with is about the importance of the user experience, but also the community and share of information to make it easier that it's okay to have a problem for something not to work. But if you branch out to a community to work together to solve it quicker, you build up momentum. And I think, like you were saying, Steen, the whole Raspberry Pi success was because of that approach with building it as a community and building it together and being able to solve the problems quicker. That sometimes you might not be able to fully deliver a great product, but actually if you open it up and collaborate, then you can solve those problems pretty damn quickly.
Yeah, and I think as we all know, kind of timing and branding are really important too, because like the company you worked for and the work you did, Paul, prior to this was pretty compelling as far as you joked about the Visio stuff, but you guys created some really nice code, a really nice developer experience. But if nobody knows about it, right?
Marketing budget does help. Lack of one doesn't.
Yeah, but sometimes it's budget, and sometimes it's just Raspberry Pi kind of ignited the imaginations of makers at the right time, right? And so it's it's almost an untraditional approach to marketing based on timing and community momentum.
Yeah, brilliant. Hey, Steen, I'm gonna have to wrap up the call because, as usual, I've got a call to go to.
Before you rush off. Next month, Jim Bennett, Counting Bears with Tiny ML. So doing vision detection and AI on extremely small boards. So kind of like the other end of the scale from what Steen's been looking at today, fully fledged meaty boards to do processing, very, very small boards to detect.
Bears or raccoons?
Yeah.
Or raccoons, yes. So yeah.
Or in the UK, squirrels.
Yeah, you'll have to ask him why he didn't choose something tinier than a bear.
Well, no, I think it was based on the fact that he had bears in his back garden.
Oh, what a great story!
Yeah.
No, Tiny ML's got a great platform. They're doing some amazing work. So I'm going to be tuning in next week to check it out. It'll be cool.
Next month.
Next month. Okay.
Excellent, Steen. Thanks very much for your time. Absolute pleasure having you on, and would love to have you on again. Sometime in the not too distant future as well. John, thanks very much for your support and help as always. My partner in crime, and I'd be lost without you. So thank you very much. If you would like to be on a show, share your insights. It's info@iotnorth.uk. We'd love to hear from you, or you can follow us on LinkedIn, Twitter, or YouTube. And thanks very much for everybody for the very kind compliments. Good night, he says, stalling whilst he looks for the outro.